So 5.8 is application. So it's pulling together a few of our ideas with right triangles before we jump and move on to what happens when it's not a right triangle, which is where we'll address the law of sines and the law of cosine. So the problems listed across the top are an awful lot, just a couple from each one. If you look at 1 through 6, we are solving the triangle, which means we're supposed to find all of the missing parts. 1 through 6 all have one angle and one side length, and then it switches gears with 7 through 12. They're all lowercase letters, which represents all side lengths. So just to pick one, we can start with number 1. Using the triangle that they gave us, I'm going to recreate it though so that I can put those specifics in. Doesn't have to be drawn to scale. It's supposed to be a right triangle though. So 23.5 degrees here at A. It's pretty easy for me to find angle B. We'll talk about that in a second. Side B is across from angle B, which is this 10 down here. So to find my little a, if I'm working with angle A, then I have my hypotenuse here. Opposite that is here, and then my adjacent side is actually the 10. So let's use 3 letters so that we don't confuse little a with the adjacent. So to find my opposite side, to find little a, I have to use the adjacent side because it's the value that I have. So the tangent of 23.5 would equal my opposite side, little a, divided by 10. So in the calculator, making sure I'm in degree mode, multiplying both sides by 10, I get that A is about 4.35, rounded to 2 decimal points. So now I could technically use Pythagorean theorem if I wanted to. I have 2 of my 3 sides. I could do a squared plus b squared equals c squared. I like to stick with what was given so that we don't have any round off error. So if I look at my adjacent side, and I'm now trying to find my hypotenuse C, adjacent hypotenuse is cosine. So the cosine of 23.5 degrees would be equal to 10 divided by the hypotenuse. This time it's not multiplication. Remember that this time when it's divided, and my hypotenuse is side C. Let's not mix up these labels. So 10 gets divided by the cosine of 23.5, which whenever, again, just in the calculator in degree mode, I get about 10.9 units, whatever units these are supposed to be in. My angles, my 3 angles of a triangle have to add up to 180 degrees, but if I have a right angle, my remaining 2 then have to be 90. 90 of the 180 is taken care of. So these were some theorems we looked at in geometry, that those 2 other angles would be considered complementary. So the measure of angle B, capital B, I really can just take 90 minus the 23.5 and end up with 66.5 degrees for that side. So 3 answers here to complete my triangle. I was missing one side, the second side, my hypotenuse, and then I was missing one of my angles there. If you look at something like 7 through 12, I now have these triangles where I have 2 of my 3 sides. I'm missing a side. And so side A for number 7 is 30.4 from angle A, angle B. Side C is 50.2. So to find my missing side, again, I can just use Pythagorean theorem to get that done. So A squared 30.4 squared plus B squared equals 50.2 squared. So I can square my 2 numbers and then subtract whatever 30.4 squared is to the other side. Or I can just take 50.2 squared in my calculator and subtract off the 30.4 squared all in one step. It's b squared, so I have to square root to get that final answer, and you should get 39.95. So this again now, I would have my side adjacent to A if I want to stick to using the same labels, working from angle A. I could use this to find my angles, but instead I'm going to use exactly what I was given. So if I want to find the measure of angle A, I have opposite and hypotenuse given to me, which is the sine. So the sine of A is equal to 30.4 divided by 50.2 because that's opposite over hypotenuse. The angle A, remember, this is the sine inverse. That's how we undo the trig function. That's why we spent that time reviewing and learning about the inverse function. So second sine on your calculator of 30.4 divided by 50.2 should give you that angle A is about 37.3 degrees. And again, if I already have angle C at 90, then angle B is just equal to 90 minus my 37.3, which leaves me with 53.7 degrees. So we don't, sorry, 52. We don't have units for my side lengths, but for your angles, you can put that little degree notation at least. So again, I have 1, 2, 3 things that I had to find. So all of the problems 1 through 12 leave me with 3 missing parts. 1 through 6 are similar, and then 7 through 12 are similar. Skipping a lot of things with bearing and amplitude, we get into just some triangles in the 29 to 33 range. I'm actually going to take a look at 33 because this one I have my 300. I have a 64 degrees in the smaller right triangle, and then I have the 34 in what would be the bigger right triangle, but I don't have this entire base length for the 34, which would be adjacent to my 34. So I'm just going to call that side A, and then this little side in here, Y, would also be missing. So if I look at my big triangle, that 300 is opposite from my 34. And if I want to find my adjacent side, then I would be doing the tangent of 34 degrees is equal to my adjacent, which I don't know, or I'm sorry, my opposite of 300, which I know, divided by my adjacent side. So this again is a division. 300 divided by the tangent of 34 tells me that A is about, number 33. That A is about 445 or is equal to 445. So if I do the same thing with the Y, if I look at now the smaller triangle, we'll do this one in green. So if I look at this little guy with the Y and the 64, the tangent of 64 degrees is equal to 300 divided by Y. So same thing, divide. And I get that Y is 146. So if the whole thing is 445, and I don't want the 146, then X would be equal to the difference in those two values, which is 299 units, however long that is. Which makes sense for the longer piece that it ends up being a little bit bigger when I think of my whole thing at 445. Then that 229 is a little smaller. That is a tough problem. A couple of the problems, 29 through 30, involve you finding two parts and adding them together instead of subtracting, but all of them are two-part questions. And looking at the answers, you can you'll see pretty quickly that we spend a lot of time using the tangent ratio with those. So once we get through the difficult problems with no context, we switch gears and look at some applications. So 41. This has one of my favorite numbers in it, so we'll take a look at 41. 42, 43, talking about angle of elevation in each of these problems. And then the ones at the end as well, if we know the angle and we're trying to find lengths, or some of them are actually finding the lengths, they're still your right triangles, your trig functions. You just need your pictures for them. So for number 41, the tallest television transmitting tower in the world is in North Dakota. From a point on the ground, 5,280 feet from my tower. Pretend that a transmission tower looks something like that. So 5,280 feet from there. The angle of elevation is 21.3 degrees. So if I have 21.3 degrees here and I'm looking up at my tallest tower in the world, then we want to approximate the height. And this really is a pretty common and practical use of trigonometry, finding those distances. If you ever see surveyors out working construction, that sort of thing. So my 21.3, I'm trying to find my opposite side over here, x. I'm not using the hypotenuse at all. I have the adjacent side, which is my base. So it would just be the tangent of 21.3 degrees equal to x over 5,280, which, again, in working through these problems, really just a review, but when my value is on the bottom, I'm dividing by 5,280, then I just have to multiply to figure out that that tower is about 2,059 feet tall.